we start the talk, I thought I'll just ask two questions to understand or to clarify what we are looking for. Can I have the next slide, please? One more thing. Yeah, just one more thing. Just, you will see a change, right? Can you tell me what is that? An apple. What is an apple? See, probably I just want to give a disclaimer. Unfortunately, I am from an academy. Okay? The professor duty is to ask questions. Okay? We remember, unless I get the answer what I want, I keep asking questions. What's an apple? You said fruit. What's a fruit? What is a fruit? Without the mic, maybe better. Can you hear me now? Can you hear me now? Or is it echoing? We can detect, we can recognize that it is an apple. But what is an apple for us?
It's nutrition to our body.
Again, if I please go ahead.
Yes, so I think when we see the image, we analyze each part of the image, we basically see the term line, and our minds have been trained to recognize it as something that's essential for survival.
Right. See, he is saying that he is seeing a shape, size, and something there. But imagine when you are a child, you don't even know what is shape, what is edibility, what is good for health, but still you know it's an apple. Correct? Then what is an apple for you?
It's an object.
It's a thing. See, difference between learning and expression of knowledge is what I'm trying to explain here. What we learn is an apple. The way we learn,
Yes.
it's a red fruit. No, I'm just talking about how you learn. See, your mom cuts, keep an apple in front, come and sit and explain, oh, nutritional value so much. Don't you know how to eat? Isn't it? So, learning is something we recognize the difference. And smart kid. How does a smart kid respond? You have a plastic apple in your hand. See the scene, right? You just keep it in your hand. Mom will be looking at you, waiting for your action. If you put it in your mouth, response is different. She doesn't come and sit and explain plastic is harmful for your body, it has so much chemical and all. No. Learning to recognize is different from expressing your knowledge. Expression of your knowledge is what we are expecting in explainability. Explainable things is very, very difficult. Detection is easy. Explanation is difficult. Understand that, right? Learning, again, another problem. I just wanted to keep all of you with me before I go further into the talk. We're all engineers, right? Some of them are from school, isn't it? It's a morning time. Let's have one simple math to refresh us. Can we do it? Let's start with a very simple thing. Addition. Okay? 60 plus 16. That's pretty good. Maybe then I'm going to do it a little faster. I want to understand. 1020 plus 1020. Plus 20. Plus 20. Plus 10. Plus 10. Very good. 2090 plus 10 is? What is the thing we have learned? It is not for laughing. I just want to bring in connection to the learning. What is that we have been learned? Do you understand what is being taught in the class? Carry to next integer. You carried that to the next integer. Does it mean you go back home, take the pen and paper, practice addition? No. Right? So what to learn, when to learn, how to learn is what different in intelligence. We know, all of us know, it doesn't mean that you come sit sincere, listen to the class. There is always a kid who doesn't come to the class, but he knows what to read, when to read, how to read. He is smarter than us. So, self-regulation, ability to ask a right question at right time makes the intelligent. So you need to understand the subtle differences. Learning is not just that 1 plus 1 is 2. If you don't understand this, the intelligence cannot be interpreted. Okay? With that, I just want to take you into my talk. Okay? So I'm going to cover up problems. Aerospace engineers, the one who generate most data in the world. The moment an aircraft takes off from the ground, lands back, we have data. Data you can't even imagine. Number of people who book the tickets, number of people who cancel the ticket, type of people who are traveling, aircraft, what goes in, comes out, engine, health, every data is available. Data is the key here, right? Data is a fuel. What type of data? How are we going to interpret the data? It is going to be spatial, it's going to be temporal data. One of the examples you mentioned about Karnataka having micro weather stations. It's a spatial, temporal. How are you going to connect these two? It is not like they have weather here and 5 kilometers away, weather will be completely different. These are connected systems. How are you going to interpret that? That's the key. Okay, so we are going to touch upon, I thought I'll just take, instead of talking about general AI, I want to connect it with what I do daily, but I'm dividing into 3 aspects. Operational aspect of it. That's autonomy aspect of it. I want my system to be autonomous. Ability to make decision. Very important. Intelligence is all about ability to make decisions. Right? Second aspect, to decide, I need information. I need data in a form I can decide. That's my perception aspect of it. Very important, distributed intelligence. This is a key. In a classroom, this is the key. It is not you learn alone. It is we learn together. Right? That makes a lot of difference. How they can work together. If I want to carry this cable down and asking 4 of you to come together, and I'm just saying that your mouth are put with a ducted tape, you can't talk to each other. But still you'll be able to carry it down. You don't tell him, I'm going to go step first down. You lift it up. No. We understand the motion. We understand his reaction and respond to it. Intelligence is all about that. Distributed intelligence. So that's a key. Okay? So I thought I'll divide this, start with autonomy, and take it to the perception, and finally end up with a much larger problem where decision is always an issue. Right? Okay. Next slide. Operational challenges are pretty high. Right? We always operate on uncertain environment. We try to see things far away. When you see things far away, you are seeing it in a slanted angle. I'm trying to see who's sitting in the back. My perception is going to be difficult because the scale is going to change. Occlusions are going to be present. Right? I cannot get his physical responses, whether is he connected with my talk or not. It's going to be really challenging. So that's one problem going to come in. All data are not available. It's like going to a doctor and say, I'm developing system for cancer. Give me more cancer data. Without data, I cannot do. Give me more cancer. It's not possible. You cannot ask for it. Right? Many a time, I have a description of the target and what I'm looking for. Large language models is coming up significantly. ChatGPT, we have a lot of things about it. I'm not getting into that. How are we going to use the philosophy of synthetically generated data, right, to real data? This is going to be a domain shift we need to understand. When you generate a synthetic data, what you see is not what you observe in a practical field. Just an example, I just put, let's say, I want to look at the launcher. right? It's very difficult for me to get actual data. I can generate it synthetically. I can put that in various contexts where the launcher could be present and learn. But when I go to the real domain, there is a simulation to real domain shift will happen. Sensor shift will happen. You see it in RGB, you go to hyperspectral. One of this was mentioned by earlier speaker, that domain shift will happen. The biggest challenge is what you can see in optical is not the same in hyperspectral. I'll show you one of the images. Can you click? One more time, please. I just kept two images at the bottom. One is optical, another one is infrared. It is also spectral. What you see in infrared is different from what you see in optical. Infrared can just tell you where the engine is. Optical cannot see below the surface. Right? If you think of hyperspectral, I can talk about much more detailed information like what is the micronutrients present, what is the water content, moisture content in the subsurfaces, which is critical for the plants. All that is possible. But how do I learn that? Domains are different. Right? Someone who studied in Canada, take him to put it in an engineering college where he has to speak only in English, learn from English. He has that difficulty. Right? Even though the knowledge is same. Expression, what you see beyond is also a problem. So there is a common, there is uniqueness. If you look at the set, right? Two sets. They have a common knowledge, they have a different knowledge. So these are the things going to make a difference. Driving in Bangalore is the most difficult thing. Why? You tell me what characteristics we should have to drive in Bangalore.
Expect the unexpected.
Expect the unexpected. What does it really mean? What is it expected, the unexpected here? What he really means? See, there is a thing you need to understand there. Intention, isn't it? What is the intent of the user? See, I'll just give a classical example. When I first deployed autonomous vehicle in Singapore, when I was working in NTU as a faculty, the dean of the institute and the president asked me one question: what are you most scared of? I said about the use, about us. He said, why? I just took him on the day. I asked him to, here we are inaugurating, this is going to clean automatically. The first thing my dean did, went in front of this and stood and asked, can it avoid me? Imagine you have a car on the highway. Will you go and check whether the driver will stop looking at you? No. Right? We see that it's autonomous, it can avoid obstacles. I wanted to check. You know what? Next day, my students came into the picture. One guy stood in front of it. Hey, it avoids me. The other guy stood on the other side. Soon everyone is surrounded. Will you do it? No. Right? Human machine interaction changes when the machine intelligence changes. Right? The level which we interact with this changes with respect to intelligence of the system. Moment I say there is no intelligence, it can hit you, you will not go and stand. Isn't it? So that is another aspect of it. Intent of the user is the most difficult thing to understand. Right? If you don't expect the intent, there is no way you can plan your motion without collision. Right? That's an important problem. Autonomy, when I want to bring in, these are the issues. Intent. How do I predict my intent? What is the user going to do? I have no idea. I cannot communicate with you. That's going to be a challenge. Now, that problem itself is difficult. Now we are complex. The problem is difficult. Right? What I'm saying, I give you a eye. Whatever you ask for. I give a LiDAR, I give a radar, whatever you want, I'll give you. Right? But still, the biggest challenge is working together. I want to lift something and carry to a particular location. Who will come and work with you? Right? Who will come? Which drone is going to come? Or which ground vehicle is going to come? First problem. Second problem is who will go to what point? You put 4 students in a project. Many of your industries know what I am talking of. Students also understand. Often work is done by very few. Having more is always a problem. Having enough contributing employees is good enough for a project. Getting that is always an issue. Making them working together is always an issue. Distributed intelligence is the biggest challenge for us. Right? What to do, when to do, how I am going to take those decisions. Who is going to be my leader at what time? It's a classical problem in learning in the class also. Right? Some student is good in some subject, some student is good in some other subject. Dynamically we change, receiving knowledge from different places. That's a key, right? How am I going to bring all this into a mission is what they are looking at. Yes. So again, some of the tasks, you need many to come together. For some, you need one after another in a sequence. Right? Suppose you want to quench the fire. Many drones have to come together simultaneously to quench. Otherwise, the job is not done. Right? It will destroy the area. You cannot have one after another. Whereas if I talk about my military colleagues, what they will say, bunker buster. I want in a sequential fashion, hit the target. Right? If I go and look at the natural disaster, there is no point bringing a bridge making machine before even clearing or removing people to the safety. Right? There are things that has to be executed in a sequence. If you go on an industry for packing the pallet, you bring the last one which has to be kept on the top. What is the point? It has to be kept there itself. Right? You want an operational efficiency, things have to come in sequence there. So, see the decision making, it changes from one to another. Okay? Next slide. So, again, systems are going to be different. They are not going to be the same. Someone will fly much faster. Someone will change its shape while going through. Moment it changes the shape, your moment of inertia will change. Your gravity will, CG location will change. Right? Actuation mechanism will change. What to control will change. So you need to have an intelligent decision making capability. So there comes an intelligent control in operational part of it. Right? You may have a smaller system. You may have a larger system. They have to work together. See, if I wanted to solve the logistic problem, right, last mile problem, right? I'm building a couple of drones and come and give it. Today you have a 5 kg to be transported. Tomorrow you may have 25 kg to be transported. For every payload limit, will I have one subsystem? And 25 kg is rarely transported. So see the issue is. So we may have multiple small things working together is a better way than one large system meant for rare occasion. Isn't it? So we need to understand when they are working together, there is a challenge. Next slide, please. Just got to keep proceeding till it goes to next slide. Yeah. Now, I talked about operational aspect of it. There are many things cannot be tested in a physical environment. Right? I need a simulated environment. What is not possible? Generating my own data, validating it. That's a key. Play the video. Click, it will play. Yeah. So, I need to have a simulator which is as realistic as possible, which can be used for generating a data, which can be used for training the network, which can also be used for validating my algorithm before I deploy it. It should be as close as possible to the real. Right? Hardware and software has to be connected so that I can verify. Right? I could have a as realistic. This is not a video. Okay? Taken from the drone. This is environment. Right? I can play, I can create sunlight, rain, snow, generate the data. There are two ways to generate the data. One, I can ask someone to drive it, export data, how we respond to the situation. I can create a situation, I can see how we respond to it. That is also a data. Because you say autonomy, right? Autonomy means I need to avoid collision. How do you know what kind of edge cases are present? Unless you have an expert playing in, expert drives, he will never have a collision. Then there is a date of the collision. For that we cannot give name user to drive because we have system is costly. See, it's a trade-off, right? So simulation is the way to go about. Sim to real is the way to go about. Okay? That's the reason I thought I'll just bring you in. So we can generate realistic data in simulation and pass the data to the network to learn. Okay? Yes. Now, moment forecasting we are talking about. Forecasting is the biggest problem because we don't know the input. If you know the input, this problem is solved. It's more like stock market. Right? It is non-stationary data. Connected system. You measure at random points. And in between what is present, suppose there is a big building is present, wind gets diverted, right? So you have to get lot more information about the environment in which it is present. We have no idea about it. What environment plays a role, we don't know about it. What we have is only measurement. Predict, that's why it is challenging. Only with measurement to predict. Right? And that's going to happen even for you. You put a vehicle and you're driving. If somebody tells you exactly the distance between you and the next vehicle, and the speed of that vehicle, and the intention of the vehicle, you will never make an answer, right? Unless you switch off your brain, he's giving a boring talk, let me just relax. Isn't it? So, the information is the key, but what you have is only I. You need that to sense that and to be alert and do necessary actions. Right? So that's where the problem comes into picture. Interpretability of the data which is present to us to estimate. We cannot measure the states the way we want. Right? You will have disturbance like this also. Right? We need to know how to remove the outlier, to filter the important information. This is the key. Right? So how do we predict it accurately? All these are connected systems. Your past is responsible for the future. Right? So that's an important aspect of it, to predict what you will be in future. Yes. See, I'm not going in detailed mathematical aspect of it. I'm touching the higher level. If you're interested, please reach out to me. I'll be happy to explain each and everything. Now, I mentioned cooperation is a key. How are you going to get connected to each other? Are we going to connect rigidly? Are we going to connect with a flexible string? What is a payload? Payload is a medical payload. You cannot swing. Right? So there is a restriction on what you carry. Right? A table with water is different from just a table with a rock of same weight. Right? So you need to understand that. So your response and reactions to the payload is more important. Right? How the string is going to play a role. You may, one of the drone, hello, can you play? The video will play. Yeah, one more. One more. Another, again, till the video plays. One more. No. Just see whether you can do yeah. So, how are you going to attach? How are you going to carry that from one location to another location? Right? You cannot have two different control mechanisms. The control mechanism should be similar whether you fly alone or together. Right? So you need to have the structure also be kept constant. Isn't it? Otherwise it's very difficult to do interpretation of that. That's an important key in this, how they come together. Now I solved this problem of they attaching together and I explained what they do, how do they attach later. I solved this, but I have another issue. Environment is not going to be this beautiful, right? You will have obstacles. Can you click the next slide, please? Can you play the video alone directly? So you may have an obstacle which is stationary or moving. You need to decide. Now the problem is, I need to know the motion of the obstacle. Right? Motion of the obstacle is a key. Predicting the motion. Safety is always mandatory, right? I cannot compromise on safety. No matter whatever you deploy, safety is very important. Can you give me guarantee? See, there is I don't know how many of you are aware of, there is a new concept called physics-inspired neural networks. They just take care of your partial, all of this can be modeled as a partial differential equations. Safety can be modeled, your dynamics can be modeled as a differential equations. If I have a network which can solve the differential equations, I'm done with that. Right? I can do end-to-end training. So that's a way to go ahead. There's a new aspect that we look at is end-to-end training with the physics-inspired neural network. Always provide you guarantee in motion. Next slide. Yeah. Now we saw about operational aspect. Let's come to the perception. Let's take a simple visual perception. The moment I go into LiDAR and radar, life becomes much more difficult. Right? Let's talk about vision itself. Let's understand what is the problem in vision. I just get one of the video, image that I have taken in a chair for you to see. You are seeing it from another angle. If your angle changes, you can see things differently. The best view is bird's eye view, right? The God's view. I can see everything. You won't get it all the time. But you need to do what is supposed to be done. Right? So your scale will change. An object which is nearby, the same object which is further away, it becomes very small. I may have to ask you, can I have 5 more minutes?
5 minutes. Thank you.
Thanks. So explainability, all this is going to be a biggest challenge I mentioned in the beginning, right? Seeing what you see is different. Exactly. So we need to know these objects precisely, whatever the scale may be, whatever the occlusion that I have, whatever the angle in which I see. And context in which they are present. That's going to be the biggest challenge for us. It's on visual spectrum. Next. What will happen if I just add one more spectrum to it? Right? Again visual. Optical and infrared together. Infrared sees things differently. Optical sees things differently. How the domain is going to help me to understand high frequency content and low frequency content present in it. Usually high frequencies are noise. What we heard a few minutes back is a noise we ignore. But high frequency do have information to detect small things. How do I'm going to learn? I need to project them in a higher dimension of space. How do I differentiate them together? Project them. That's going to be a biggest challenge. Now, one is that. Second is whether you have a cat eye, whether you have an eagle eye, I don't care, but I want you to detect so that you can avoid. How am I going to fuse this information? See, it's going to be a problem because in the beginning I mentioned infrared show you engine. If engine is hot, you will be able to see it. If the engine is not hot, you will not be able to see it. Right? Optical sees certain surface level features. There is something common, something which is not common. How do I know what is common features, what is not common features? The beauty of our mind is we learn to identify things in hyperspace which we cannot explain. That's why I was just bringing in Apple's case in the beginning. We don't know what is Apple really for us. Why? Because our knowledge is a problem. If you have a sufficient knowledge, you will be able to express what is in your brain. Right? We have a way to project them in a hyperspace where they are correlated. I don't know that hyperspace. Right? If I know the knowledge of that, I would be able to explain to you in much better way. Limitation is about the knowledge, not the relationship between these two spectral space, which will help us in detecting, recognizing. That's the point I want to bring in. Next slide. Very important issue. Let me not take this. How many of you know Komodo dragon? Have you heard of it? What is it? Komodo dragon. It's a type of reptile.
It's a large reptile.
Large reptile. So many of you have not seen. It's a large reptile, thick skin, long tongue. You can make out now, right? If I show you a picture, you'll be able to reconstruct it. That's the beauty of the human mind. That's the beauty of the AI also, generative AI. There is a relationship between text and visual feature. If I can connect the text and visual feature, I can recognize things without even seeing them. I thought of the example bringing an armed vehicle. I know the car. I know this armed vehicle. What do you mean by armed vehicles? Right? I can give a textual description. Vehicle built with text and places mounted with a gun. Good enough for you to imagine what is that vehicle could be. That's what zero-shot learning is all about. Right? Without seeing, I have ability to detect. Next slide. Next slide. Okay. 2 minutes, I'll be done. Swarms. Why I brought in this topic to all of you was distributed intelligence is key. Right? We live in chaotic world where things are not stationary in nature. Right? So collective intelligence is very important. Resilience will be there. Right? And we have a multiple perception to make decisions effectively. Okay, please. So we have network. Connected people will always perform better. So you gather more information, intelligence to interpret. Right? So that makes things different. And one more thing. So we live in adverse environment. Take it of fire, take it of natural calamity, take it of even normal operations. We live in adverse environment where we cannot predict how much time it will take for us to reach home from here. Right? So distributed intelligence is a way to go about it. But it has its own challenges. Next slide. Next slide. I can talk about problems, where this makes a lot of difference, perimeter difference, right? I wanted to see who's coming inside my room or who is coming inside the airport, can I look at it? Whoever comes inside that particular area, can I protect and capture him, right? I can talk about various problems like that. Forest fire, the biggest problem in our country, right? Fire spreads like this. It's not like stationary. It's dynamic. It depends on so many factors: moisture content, carbon content, wind direction. Everything is going to affect, right? How am I going to minimize the loss using all these intelligence? It's a key, isn't it? I can talk about convoy protection. I can talk about it. All of this. If you see, single person cannot solve the problem. You need multiple systems with a collective intelligence to come into picture. Next slide, please. One more thing. Again, yeah. Click till I get it. You have a problem with the partial observability. You see your friend. You see something in future. You want to study that. Your friend doesn't see you. You ask him to come and join with you. He will not. He doesn't see the importance. This is a problem we also face as an educator, right? They have to see what we see. Observability is a problem. Scheduling, you have multiple sensors. Which one to use what? Which information to be filtered for what decision making? That's going to influence a lot. Target, the nature of the target, type of a target, all that is not same at all times, right? Biggest problem is sometimes I can do it alone, sometimes I need two people to come together, sometimes I may have to make sure the task can be completed by us alone, right? I don't want 2% to come. How do I do this, right? That's where the distribution intelligence becomes much more interesting. communication limitation. You cannot send whatever you are seeing to your friend. You need to interpret. The biggest problem is no free lunch theorem. No algorithm is good for all the problems. It is different for different problems. How do we take advantage of that? As an individual, it is a problem. But collective, it is not a problem. How do I take advantage of that? Cooperative learning, distributed learning is the way to go about. Always be encouraged in the class to work together. Why? Because if you don't understand, there is someone there to explain you to bring your level up. Right? So, mentoring, dynamic mentoring will happen in distributed intelligence. You don't have to depend on the teacher alone. Next slide. So, way to go about, okay, that's all learning side. Way to go about, learning is a game. I call it deity. Okay? We need to make deity. Distributed AI technology to help partial applicability, decision-making ability. They need to have, see, driving is a skill, right? What skill you need at what place is different. How do you know which skill to be applied? What is a policy that you want to learn is the key of the future, right? Some of these topics I'm just touching upon, not going in detail. I think with that I will stop. I thought I'll just explain it one problem. Key is taking inspirations from the way we learn in life to program the AI to do what we want, right? Rather than AI program as a decision directly for our daily operations. There is a task which is mundane task, there is a task which requires thinking. We need to differentiate this and solve that particular problem. With that, I'll end my talk. Thank you.
For appreciation.